Well, good evening, everyone. I'm Ken Cobb, and welcome to the second of six Dynamic Object Network virtual meetings hosted by the Institute of Conservation in the UK. I noted in my last introduction to a Dynamic Object Network meeting in Cambridge that everyone had travelled to the meeting using a dynamic object, whether it be a bicycle, a car, or something else. But where will these objects be in 100 years' time? Probably as an image in a photograph in less time than we could have imagined a few years ago. That is another story. However, the point is that this network is very wide-ranging in its interests and embraces input to and output from all interests under ICON's umbrella. That's metals, paper, ceramics, textiles, wood, and of course, the photographic image, just to think of a few. So I think a few members of our audience will have specifically used a dynamic object to attend, yet the only item that I can think of, which has now dropped off the radar, is the mechanical mouse. But even that has been replaced by the optical mouse or the mouse pad. Conservators are always thinking or always asking questions about the appropriateness of their proposed treatment, especially where movement is involved. This network was set up to enable these questions to be asked to carousel techniques which have worked with an aim of setting out assessment guidelines and giving pointers about possible approaches and their risks. The network's range of moving objects is extremely diverse, from the smallest instrument to the largest, and it's a very brave person or a fool who tries to list them all. Let's move on. Our four presentations this evening are just as diverse as in our first meeting a month ago. We will run from talk to talk without a break, and if you wish to comment, then please use the live chat facility. Thus, we open with Fjodor. Thanks, Fjodor.
Right, thank you, Ken.
Right.
Let's see, so I now do screen share, and I trust everyone can see this okay? Good. Just a little bit about myself. Good evening, everyone. My name is Fjodor van den Broek. I'm a horologist conservator for the Royal Collection Trust. I'm based in Windsor Castle. My short talk is going to go about the challenge of maintaining clocks in a working collection. And to start, what is a working collection? A working collection is an often historic collection of decorative arts, which is still in use for events and functions. For example, the Royal Collection that the Royal Collection Trust cares for is used for both state and private events, and as such is subject to the same wear as contemporary furniture and common faults. Common faults and breakages can therefore also occur. These breakages and faults naturally mean the objects have undergone conservation, restoration, and repair, and will in the future still need to undergo conservation, restoration, and repair. And this, of course, means the loss of original material. And this shows the two-edged sword when talking about dynamic objects or just any object in a working collection. Do we conserve the object or do we conserve the function? Both sides of the two-edged sword require a different approach. If objects are kept in their dynamic function, regular checks will be required. And if any minor damage has occurred, the object can be serviced by a conservator before it becomes major damage. The objects will need to withstand the same daily use as their modern counterparts. And objects in a working collection will often be moved by non-conservators, but as they will be in a condition ready to be used, this should be no more of a problem than with modern objects. Lastly, dynamic objects in a working collection might need to withstand longer periods of wear, depending on the amount of objects in the collection before they can get treated. On the other side, of course, then there's the conserving of the objects. Where objects are not used and clocks, and on any other dynamic objects, will either be kept static or only ran on certain occasions. This means that treatment to the inner mechanism won't be very radical, but only to keep the object stable for the future. A stop clock won't carry out the function they were made to fulfill, but the loss of original material is kept to an absolute minimum. Now over to Windsor Castle. The state apartments in Windsor Castle show some of the highlights of the royal collection to the castle's visitors. And like I said, in the second slide, are also used for both state events as private events by the royal family. The public is not to interact with any of the objects. As for clocks, my specialty, the state apartments are home to 26 clocks, and a further three clocks are also on public display in other parts of the castle. To make sure the clocks are always behaving themselves for the public, I go around and check them every morning before the public comes in. And if needed, I will give them a stern talking to make sure they're on time again. Windsor Castle and the surrounding Greater Park is home to over 400 clocks of the royal collection, housed in the state apartments, offices, and any other room that requires a clock. This also includes 6 turret clocks. Almost all of these are kept running and keep the castle on time. I try to keep them within 3 minutes plus or minus a week, but as some of these clocks are well over 200, if not 300 years old, this might be a struggle. So in my weekly rounds, I always check the clocks for accuracy and adjust them when needed. The clocks are wound on set days per week. My weekly schedule involves about a day and a half worth of winding all 400 clocks. And during winding, I also check the clocks and the cases for any damages and check their functions. Because the beauty of me going around every clock once a week, I get to know all clocks very well, and I quickly can find out if there's a minor malfunction to any clock. If I then do spot this, I can stop the clock and take the clock to my workshop as soon as possible to prevent it from becoming a major breakdown. It's almost like doing a checkup like you would at a GP. As soon as something feels or sounds wrong, stop and receive treatment. Depending on the clock's location, if I take a clock back from, for example, from the state apartments, a suitable replacement will be found as well, which then can take its place. So there's always the ticking that the visitors love in the state apartments. Some of the other activities in my daily weekly life is caring for the horological collection of the royal collection. Includes working together with the Buckingham Palace horological conservator and other conservators, part of the Royal Collection Trust, and a collection information team. When a clock move is required, I can either do this by myself or ask the help of the castle attendants. For some of the clocks we have on site can be over 200 pounds, and which requires a little bit more manpower to move them. Clocks that are not currently used are kept in a storage room next to my workshop. From here, they can be taken out, serviced as needed, and go out into the castle as either replacements for any clocks I take back to my workshop, or when a clock is requested for a new location. For example, a beautiful mahogany kitchen dial clock by Benjamin Lewis Vullemy will be moved to the castle admission center in the coming week. So any people who are watching this and want to come see the collection, when we reopen next Monday, there's one more clock on display for you to view. Lastly, I assist the collection's care team in preventative conservation. If they have any questions regarding clocks, I can answer them. And if I have any questions regarding the environmental monitoring or just preventative conservation in general, I can ask them. So we have a whole team of collections care, conservators, collection information, all working together, making sure the clocks are, and all other objects are always looking their best. And also to make sure, like I said before, if there should be a minor malfunction, we can remedy that before it becomes a major malfunction. Lastly, I also provide training in the carrying of clocks. For example, the housekeeping staff who are in charge of the daily cleaning of the castle. I've trained them on what to do when cleaning clocks, and most importantly, what not to do when cleaning clocks. The castle attendants are trained in moving the objects in the castle, and some of those objects, of course, are the clocks. So if a clock, like for example, a 200-pound clock I just mentioned, needs to come back to my workshop, they know what to do in helping me get the clock as safely as possible to my workshop. And lastly, salvage training is also given in how to safely remove clocks from a building in case of an incident. I'm not sure if everyone who sees this knows, but in 1992, there was a bit of a large fire in the castle. Thankfully, the teams in place at the time were absolutely great, and only a minimal number of objects were lost due to the fire. And the salvage training means make sure that should an incident happen to occur again, and touch wood that it doesn't happen anytime ever, at least the objects will be safely saved out of the building. So this is just really in short some of the challenges that I undergo on a weekly basis to make sure the clocks in the castle are running, stay running, and will for a long time keep running and keep the castle on time. If there are any related questions, please post them in the chat. I think there's a Q&A section. And lastly, I just want to say all the clocks you have seen in the pictures in this presentation are on public display in the state apartments. And like I said before, next Monday we are reopening to the public. So if you go to the website you see right now on screen, you can book tickets and come see the clocks and many other beautiful objects for yourselves. I want to thank you all. I want to thank Matthew for setting all of this up and for inviting me to come say something as well. And I think I'm now going to hand you over to Ken, who's going to tell us something about a specific tower clock. Thank you all.
Okay, it's Ken here. I'm going to share my screen. If I can find it, there it is. Come on. And we'll go from the beginning. Okay, right. Good evening, everyone. I'm Ken Cobb. Thank you, Fjodor, for your enlightening presentation about Windsor Castle. I'm going to consider what could be done with a corroding tune player. I look after the turret clock here, that's in Framlingham. So I have regular access to the room where the turret clock and tune player reside. Since my line of work is in the conservation of dynamic objects, principally clocks, this presentation is more of my thinking aloud, to which I invite from yourselves further thoughts and comments. Thus, I will show and discuss a number of facts of this tune player interwoven with my thoughts and questions as to what to do next. Across the mere, one sees the town's castle, with the top of the church tower poking out through the trees to the right-hand side. Everyone who knows about it in the town refers to the tune player as a carillion, but a Wikipedia definition is that a carillion is an apparatus that strikes on 23 bells or more. This view of St. Michael's Church, which was built between the 14th and 16th centuries, stands in the town between the market square and the castle. The tower houses the turret clock and the tune player, as well as a set of 8 bells in a bell chamber above. The turret clock was installed in 1872 as a gift to the town upon the death of Mr. Thompson, a local man who became Queen Victoria's principal surgeon. It is owned by the town council. To take this photograph of the tune player, I stand with the turret clock on my left. The tune player is made of wrought iron and is set in a wooden frame. It rang on the 8 bells. It was weight driven, but the weight and the rope have been removed. The tune barrel, which is seen here, is about 1 meter in diameter. The tune barrel consists of strips of wrought iron set around the circumference, between which are jammed lifting pins. As the barrel rotates, the lifting pins lift hammer arms, which are connected to the bell hammers via hammer pull wires. The system works in a similar manner to a music box. I and the town council do not know when it was installed or who officially owns it. There is no maker's plate on it. It was reported in the parish news of 1964 that the carillion last worked at the end of the Second World War, whereupon it played one tune every quarter of an hour, and the townsfolk got sick of it. At the moment, there is little interest in doing anything to it. To the left is a frame holding 18 hammer levers, and on the top of the picture one can see the circumference of the tune barrel with one lifting pin just visible. Hammer pull wires are connected to each, or were connected to each, hammer lever at the bottom of the picture. The hammer pull wires and hammers to each bell have been removed and are not to be found. Inquiries were made about 20 years ago for the reinstatement, but the cost of materials and fittings alone was completely prohibitive. The right-hand image shows 8 bells in the tower, which are rung enthusiastically today. For those who are interested, more information is available on the church's website, and they are looking for local volunteers to ring the bells every week, although not quite at the moment with COVID-19 restrictions in place. Progression of the tune barrel, on the left-hand side, progression of the tune barrel is controlled by an 8-notch count wheel, seen here in the center on the left-hand image. A count wheel stop arm is seen towards the 11 o'clock position of the count wheel. This would have been momentarily lifted by a mechanical tie controlled by the tower clock. The apparatus would have rotated until the count wheel arm dropped into the next notch. There is no speed control fly apparatus at the moment or at present. To the left and right of the image, one can see the backs of the lifting pins of the tune player's last songs. The right-hand image shows the wooden weight barrel, which is actually rather diminutive in the picture. And there is no sign of rope or weights. I assume the wheel next to the wall was used to wind the tune wheel, using a looped rope that enabled winding to take place in a more accessible room lower down the tower. Note the condition of the remaining parts is satisfactory in that there is some corrosion to the iron components and there is little sign of woodworm in the wooden framework. I can rock the tune barrel, indicating its bearings are not jammed solid. So here we have a dynamic artifact which is part of the town's heritage, yet little interest is being shown to do anything with it. Its static condition is sound, but work is needed in the near future if it is to be kept. I have no idea if this design is unique or particular to East Anglia, or if tune players are common in East Anglia. I believe a decision is required soon about its future, even if it is to leave the object to rot. Prior to this, I think a short study is required to gauge local feelings and to understand a range of options, typically to leave alone, to stabilize, to restore, or to remove to the local museum or to model it. And a little more of the tune wheel's history wouldn't go amiss. The study would need to include costings of options, identify professional and volunteer involvement, and identify health and safety concerns. Thus, this presentation has considered the first stages of a potential project as to what to do with the old dynamic object, which is not in a state of serious disrepair. Please place comments and raise points through live chat, so that with this in mind, I now hand you over to Daniela for her presentation. Okay, Daniela, I'm going to stop sharing now.
Okay, thanks, Ken.
Right.
So here we go, sharing screen and slideshow. Okay, hi everyone. Thanks for that talk, Ken. And my name's Daniela, and I'm the Horology and Scientific Instruments Conservator at the Royal Museums, Greenwich. This museum group encompasses the National Maritime Museum, the Royal Observatory, the Queen's House, and the Cutty Sark, all based in Greenwich, London. In this 10-minute presentation, I'm going to talk about my research into the use of Arduinos in the context of dynamic object conservation. This topic formed the basis of my master's research project, which I completed at Westdean College in 2017. Firstly, I will introduce the Arduino platform, both its software and hardware capabilities. Then I will present some of the uses for Arduino in conservation, including simulating, prototyping, and monitoring. And finally, I will talk a bit about the ethics of using Arduino technology in conjunction with historic dynamic objects. So let's start at the beginning. What are Arduinos? Founded in 2005, Arduino is the company name of an electronics platform that provides affordable open source hardware and software to enable quick and easy prototyping for electronic projects that interact with the environment. The first thing to explain is that the Arduino printed circuit board, which you will see on the next slide, is essentially a tiny computer which runs blocks of code, also called sketches. This image shows a page of the sketchbook, the digital space where the user creates commands based on inputs and outputs of electricity. Although the Arduino is a highly sophisticated piece of computer architecture, it is branded using informal language such as Sketch and Playground to encourage wider participation and counter the typically inaccessible and hyper-specialist nature of computer programming. The software is free to download and is open source, aiming to empower users, increase the scope of application, and propel product development, as there are no license or permission barriers. The open source ethos promotes individual creativity and demotes gatekeeping. Here is an example of an Arduino printed circuit board, or PCB for short, onto which the sketches can be uploaded via the USB connector. This is the Uno board. There is also a variety of other boards, including the Mega, Leonardo, and Nano, which all boast slightly different capabilities. The pins along the top and bottom edge allow shields to be connected, or wires can be plugged in to link up other physical computing devices, such as sensors and actuators. These hardware components work on two basic electronic principles, sensing and actuating. Sensors convert some aspect of the physical world into electricity, whereas actuators take electricity from the PCB and convert it into something physical, which we can interpret with our senses, such as motion with motors. These hardware components are Lego-like. They slot together, eliminating soldering, which enables quick configurations to be trialed in a non-precious way. The following examples of dynamic object conservation projects predate the widespread use of Arduinos. With each case study, I hope to show how employing Arduino technology might simplify some of the treatments or add further capabilities. Ken, this might give you some ideas. The first case study regards the simulation of mechanically produced audio. In 2010, a project was undertaken at the Wallace Collection, London, which involved these two 18th century spring-driven carillion clocks and took almost 4 years to complete. To ensure audio information was not lost due to the fragility of the striking mechanism, the 14 melodies of each clock were recorded onto high-quality MP3 files, allowing digital playback options to be explored. The team encountered difficulties in activating the digital playback from clockwork elements within the going train, as this was to be kept in operation, and also in producing a final configuration which was small enough to fit inside the cases of the clocks. Note that the board pictured here is not the Arduino hardware. Switch options and size are non-issues with Arduino, as the available hardware offers a range of photo and motion and other sensors, as we have seen. And the Arduino Nano is a smaller PCB measuring only 18 by 45 millimeters. The next case study employed discrete electronic components to replace the clockwork gear trains of an automaton clock. Discrete components are single units which perform a specific function and are connected in a circuit via soldered wires. The pagoda clock, manufactured for the Chinese export market, became the subject of a 3-year conservation project beginning in 2012. According to those involved, including Matthew, the treatment was successful yet challenging. The biggest problem with discrete electronics hardware is that in order to change or refine the performance of the circuit, components have to be either modified or replaced. Thus, fine-tuning the desired operation becomes laborious and potentially costly if new components are having to be bought for trials. In this case, using Arduino hardware would allow variables to be amended within the software codes, the sketches, without necessarily having to change the hardware configuration. The final case study is the Finter's carousel, which is used to demonstrate monitoring a motor-driven object. The Finter's carousel was the case study for my MA research project. You can see in the images the overall object on the left, as well as the assortment of unearthed wires and components that give or gave life to this 20th century model. Pictured here is the Arduino hardware configuration, which served as a demonstration to illustrate the potential for monitoring a historic motor-driven object using Arduinos. The concept behind this demonstration is designed with a functioning object in mind. So as the motor wears, or its lubrication dries up, or debris clogs the motor, or some other eventuality begins to interfere with safe and ideal operation, the power to the object's driving force will be automatically shut off prior to any major damage occurring. So how exactly does it work? Well, the Arduino is programmed to drive the motor at a constant speed of 40 RPM. The photosensor, which is here, if you can see my cursor, monitors the speed of the encoder wheel, which is this black and white wheel, detecting any resistance through changes in speed. If resistance is detected and the motor speed decreases below 40 RPM, more power is supplied to the motor to reinstate the programmed speed. A preset parameter is built into the sketch, instructing the power to shut off if the parameter is reached, and a flashing warning message is simultaneously activated. Target variables such as preset shutdown parameter, warning message, and speed of motor can all be adjusted in the sketch to ensure the monitoring remains calibrated to the object's present state of activity. This also highlights the possibility of adapting the monitoring device to fit other historic motor-driven objects. Another advantage of employing a robot such as this to monitor an object is that Another advantage of employing a robot such as this to monitor an object that is in constant or regular operation is that the driving mechanism in historic objects are often hidden, so it is not always easy to preempt damage until it is too late. Are Arduinos viable from an ethical perspective? Well, that's a difficult question, but I tried to answer it by carrying out my Arduino monitoring demonstration at 2 public events, the Museums and Heritage Show and the West Dean Open House event. At both these events, the public engaged in a questionnaire and discussions surrounding authenticity, craft, and the use of non-native technologies to preserve the function of dynamic historic objects. The conclusion was that the initial response to the Arduino was adversity and suspicion, but following the Arduino monitoring demonstration and further explanations about how dynamic objects are generally destroying themselves through performing their function, both specialist and non-specialist audiences could relate to the benefits offered by such technology platforms. By adopting the open source ethos of participation and making specialist information freely available, I found that the audiences appreciated learning about the conservation challenges we are faced with when trying to preserve functionality. And thus, without actually carrying out any physical treatment to my carousel case study object, its status was elevated by the transparency of the research I had carried out. Finally, I'm sure there are other projects like these out there. So if you know of any or have carried out any conservation projects with Arduinos yourself, I would be really interested to hear about it. So please get in touch. Thank you for listening, and I'm going to hand over to Dale now.
Thanks, Daniela. Get this up. Yeah, thanks, Daniela. I was at West Dean whilst Daniela was doing that project as well. I was in my first year. A lot of interesting conversations about, you know, these ideas of non-native technology and you know, is it ethical to display the sort of perception of function without the original function, and this idea of functionality comes up in dynamic object conservation all the time, so that's what I'm going to talk about a bit in my presentation as well. So I'm a clock conservator based in West Sussex. Most of my work is what I guess we would describe as a commercial setting. Most of my clients are owners of single objects or small collections of a few clocks. And there are normally none of the sort of conversations that sometimes take place in institutions about whether or not an object should be run. The implicit assumption is generally that the clock is to be functional and normally on a continuous daily basis. The clocks I work on are more often than not of fairly low financial value, but they often have high sentimental value, and the clock I'm going to talk about today is one such example. Something that I also want to mention is, and this kind of relates back to what Fjodor was saying about conserving function versus conserving the object, is it's a dilemma that you often face in dynamic objects, is you have to kind of intervene with materiality often in order to maintain function. And an example that is relevant to what I'm going to talk about today, in her book Conservation Treatment Methodology, Barbara Applebaum talks about damage being significant at times. So sometimes where a conservator might want to address damage because it's detrimental to the object, but sometimes they might want to keep or even highlight a piece of damage because it is relevant to an important part of the object's history. And she uses a teapot, I think, as an example. And that's really easy to do with a static object. If it's damaged and you want to keep that damage to highlight it as part of the object's history, not a problem, because it's not going to be used. But in a dynamic object, you have to kind of weigh up whether that significant damage has the potential to cause even more what you might call unsignificant in conservation context, but significant in material context damage. So the clock I'm going to talk about today is this one pictured here. You can see it's signed for George Milnes of Nottingham. According to the owner, who lives in Sussex, this clock has been in his family since it was first made, when his ancestors were Nottinghamshire farmers. And this link to the family past is a big part of its significance. However, what is also of interest is that this clock was in his grandparents' house in London during the Blitz, and the house was destroyed in the bombing. Fortunately, his relatives were in an air raid shelter, but the clock was severely damaged, and it was rescued from the rubble by the current owner's father, and apparently repaired by him. I'm not sure, it's unclear whether or not he actually did much of the work himself, or if he found someone to do the work. But judging by some of the relatively crude repairs, which we'll see in a minute, he may well have done it himself. So here you can see, this is why the clock was initially brought to me. On the left, you've got the click and click spring as it came in. So this is a rather crude replacement click spring. And basically it fatigued and it was no longer springy. In technical terms, it was undergoing plastic rather than elastic deformation. So when the clock was wound, it wasn't re-engaging the click and the weight was just falling to the floor without providing any power to the gear train. A fairly straightforward fix to make a new hammer hardened spring and refit it via the existing screw holes. But what the owner did tell me was the clock had actually not been serviced for 30 years. It was because of this particular failure, but it became very apparent when I initially examined it for estimate that there was a lot of other problems as well. I'm not going to talk about all the issues I found, otherwise we'd be here all night, but I just want to focus on a couple of things. So this is the worn wheel. You can see on the left some of the crude historic repairs that I was talking about. 3 of the 4 crossings on this wheel were damaged, presumably in the bombing. 1 completely beyond repair in the bottom, you can see there, and 2 that have been reinforced with lashings of hard solder. And the wheel also runs very much out of true in the plane perpendicular to the arbor. Unfortunately, I don't have a video, but it is actually quite amusing to watch it run. I think that many restorers or repairers would be sorely tempted to replace this wheel. It kind of looks a bit risky to leave it. But as Jonathan mentioned in the last of these sessions, conservation is about having minimal impact on the materiality of the object. And I felt that with a bit of reinforcement with some soft solder at what looked to be the most at-risk crossing, which you can see the post-repair picture on the right there, I actually felt like this wheel could continue to serve its function with minimal intervention. As a warning wheel, it does undergo a physical locking action, which can be somewhat abrupt. As you can see, what I decided to do was remove some of the excess lump of hard solder because it added a lot of weight. So from a physical mechanics perspective, the greater the weight of the wheel at the rim, the greater the inertia when it's spinning, and consequently the greater its resistance to any changes in its motion. So that means it's more of an abrupt stop if it's heavier on the rim. So I felt from a functional perspective, by removing the excess solder, I was aiming to reduce the potential for damage to the wheel when it undergoes locking. And this felt justifiable considering the solder is obviously not part of the original material of the clock, but it's a later repair. But this idea of significant damage or, bad repairs being significant is part of the history of this clock, that it was bombed and underwent this damage and was subsequently repaired, not necessarily in the most professional way. And conservation is not just about the impact to the original materiality, but it's about what is important and significant to the stakeholders. And in this case, the fact that his father repaired the clock makes it significant to the current owner. So whilst crude and not particularly functional and perhaps mildly detrimental, that big lump of hard solder is part of a group of repairs that are significant. And on reflection, I think that perhaps I should have left it, and I'm not convinced that that was the right decision to make to remove it. So last time, Jonathan also, I just saw Fjodor's face when he saw those. Last time, Jonathan also talked about pivot polishing. As I'm sure many of you here are, I'm in total agreement with his thoughts. There's no need for a totally smooth burnished pivot. I tend to regard the light burnish to remove burrs or sharp edges to prevent further wear, but this generally means that much less bushing is required. At Allnuts, where I'm based, and few of the other clockmakers in my sort of local network, we refer affectionately to any scoring left in the pivots as oil retention grooves. But these pivots here on the left were definitely beyond a light burnish. This is what 30 years of constant running without a service or proper oiling gets you. These are the front and back escape wheel pivots. And when they gain this sort of mushroom shape, if it's mild, they can be filed down to parallel so that they have an adequate bearing surface again. But these were so heavily worn that to get them down to an adequate bearing surface, they would have lost a significant amount of diameter, and they just would have been far too thin to be stable. So they had to be replaced completely by drilling down into the body of the arbor and pressing in a new bit of hardened and tempered steel. And there's an example there on the right. That's one of those pivots replaced. Now this pivot is on the hoop or locking wheel. It's the front pivot, and you can see that there's a significant stress fracture in that pivot. The bearing surface itself is not, significantly lost, but that stress fracture goes right the way through the diameter of the pivot and up into the arbor. And you can see someone has pressed and soldered a brass ring onto the arbor to reinforce it. I was happy that the reinforcement to the arbor was stable, but it felt like a significant risk leaving the pivot, since if it were to fail, if that stress fracture were to give way, the wheel would basically fall out of meshing, completely unlocking the train of gears and potentially causing quite a lot of other damage elsewhere in the train. So in the interest of keeping the significant repairs, I really wanted to just replace the pivot and keep the brass collared section of the arbor. But unfortunately, this arbor is actually also bent as well, which made the whole operation a bit trickier. But removing the pivot also found that the stress fracture literally goes bang through the center of the arbor. So trying to drill a hole central to that arbor, I was breaking drills because they were catching on the sharp edges of the fracture, or they were wanting to wander away. So what I basically got to the point where I could see no choice other than to completely remove the fractured section, which meant unfortunately losing that really kind of nice and unique historical repair, and then rebuilding the arbor with a full extension, which gave this result here. This particular repair was going to prove continuously troublesome for me. So once the clock was finished and tested for a couple of weeks in the workshop and delivered and set up back in the client's home, I got a phone call about a week later that the weight had fallen to the floor. And when I went to have a look at it, what I found was something like this on the right. So on the left is a diagram of the repair that I've done. And on the right is what happened. So whilst there was no longer any visible stress fracturing in the point that I had drilled into the arbor, it was obviously still weakened. And this being the locking wheel, it undergoes a significant abrupt locking force after every striking cycle. And the arbor had basically failed so that my extension was able to fall out. And so the very thing that I was trying to prevent with the repair had happened. The pivot failed, the wheel fell out of meshing, and the train unlocked. Fortunately, there wasn't any other damage caused besides some slightly bent lifting pins, which were fairly easy to straighten up. So obviously I had to remove the broken part of the arbor and take it right back to close to the pinion and then fit a new extension, like this example here. Tested it for a few days, returned it to the client. 2 weeks later, I got another phone call and it had failed again. And this time it was actually my new material that had fractured. A sharp angular step in a component like this is always going to be a potential weak point. And the powerful locking force was obviously too much for the small diameter of the extension shank to withstand. So by this point, the client was talking about whether or not the entire arbor itself ought to be replaced, especially considering the arbor was bent as well and there was some wear in the pinion. But I felt certain that we didn't need to lose the whole original arbor. So I did this. I drilled out the hole as big as I dare, which was a 2mm diameter hole, basically. And rather than fit an extension with that angular weak point, I just fit a straight piece of bar with a pivot turned on the end. This meant that the new extension was no longer quite at the original diameter of the arbor. So it was an aesthetic compromise made for an improvement in strength. I tested the clock for another week and I delivered it about 10 days ago. I've not heard anything, so I think that this repair has got the strength that it needs. In hindsight, looking at this clock and this repair, the original stress fractured pivot had obviously been that way for at least the 30 years since the clock was last serviced. And likely it occurred during the bombing. So that's 70 years plus, and it had never failed. And I repaired it and it failed twice in 1 month. We'll never know if that original pivot would have held out for the next 10 years or how long it would have held out. But it is very difficult to feel like I did the right thing in this instance. I would say that I had the best intentions from a conservation perspective. I wasn't doing it because I thought, oh, well, that's just not right. I've got to do something about that because it's wrong. I had genuine concerns for the functional stability of the object. And this is where the dynamic object dilemma comes in, when you've got something that needs to maintain functionality and you have to make choices that if it was a static object, you wouldn't have to make. So you're trying to balance originality, significance, and stable functionality with dynamic objects. So there you have it, some well-intentioned, but potentially not the best conservation decisions on an object where balancing functionality with significance was a bit of a tricky act. I know that Matthew said he wants these sessions to build on each other. And it often feels like when you see presentations or articles on conservation, most of what you see is the really clever or innovative stuff. But conservation does go wrong. And I hope not always through lack of skill or judgment necessarily. So I'd like to think that we can learn from each other's mistakes, or there's interesting conversations to be had. So I hope maybe we'll see some more talks about conservation gone wrong in future as well. So thank you all very much. And I will hand back to either Matthew or Ken, who's going to close the session.
Hi, Dale. Thank you for that. Thank you, all our speakers, for great conversations. Just a little bit about at the end of the talks, that Dale's absolutely right. The point of these short talks and presentations is to build a conversation. So that's why we've deliberately kept the whole thing quite informal with the live chat, so we can carry over from one session to the next, which is why we're delighted that we've been joined by Seth as well from last time. So Dale, interesting there that, as you say, I think particularly as a beginner in horology, I remember all those decades ago, there's a kind of tendency for us to think that everybody's amazing. So a big pat on the back for your frankness there, because of course, everything goes wrong all the time. And that's sort of really the dialogue. I think maybe linking to what Daniela said, in a research on Finter's carousel, the dialogue is actually as important as the interventions, because it's through dialogue and through sessions like this that we actually extend our practice. So there are some questions. The first one from Julius. Hi, Julius. Good to see you there. And it's, I think, probably aimed at all of us and maybe Seth as well from last time. But Fjodor, in the first place, because these objects are kept operating in that very specific context, and beautiful to see inside those rooms, What kinds of decisions, and what I'm interested in, what kind of team, or how far does the decision go when you're replacing, like we saw the spring from Dale's clock? How does that work in the context that you are, sort of originality, new parts, function, safety? How would you go about that in your job?
So for us, it's mostly the conservation of the function. So I think we would take the step to replace a part a bit sooner than others might. But one thing to not lose the original material, what we do, and thankfully I've got a nice box with assorted parts, all with in envelopes and boxes related to the clocks, is previously removed parts that had broken. So a broken click wheel, broken click, levers, wheels, you name it. So which have been replaced. So if, for example, I had that 2 weeks ago, a click is worn through, that it will take a lot of removal of original material to make the click work to original function again. I would sooner take the option of taking it off and making a new click, and then keep the click in the box of previously removed parts, write down the number and the name of the clock I took it from, and write it down in the clock's history in the treatment report. But I do think that's something that mostly works for collections as the Royal Collection, which are closed. There's not a large chance of any clock going anywhere else sometime soon. So all the information and all the parts that are part of the clock's history will stay at least in the same building as the clock, if not the same organization as the clock.
Anybody else got, because we're all dealing with these, I mean, these questions are universal. Different perspectives. Dale, as you said, you're coming at it from a slightly different angle, being the self-employed practitioner.
Yeah, sorry, Matthew. I was just answering a question.
Sorry.
I didn't quite. Just typing.
I mean, it was what your whole talk was about. Really, it was about that sort of dilemma between trying to anticipate. What I've seen recently, and you know, and particularly maybe it's because I'm looking at things like Facebook fora, but we get sort of disaster situations. I get that the whole time. Oh, well, what happens, like you had, you know, if the pivot breaks and then it does this and the weight falls through the floor. I think it's quite difficult to push back against that kind of thing, but I suppose we have to do in balancing the whole dilemma.
I would think, it's Ken here. I would think though that you know, the difference between Dale and Fjodor is to do with you know, in the case of the castle, you've got to withdraw the object before it fails. And so you are looking at it all the time, assessing it, noting that it's slowing down or whatever it might be doing. Whereas in anything that's brought to us, you know, it's failed. And you know, the damage has been done.
Absolutely. And there's also a very different thing in terms of context when things are brought to you in a commercial setting. Whilst, you know, I give a 12-month guarantee or 2-year guarantee, those are the kind of common guarantees people give. We might be giving only a year guarantee, but really people are expecting that clock to run for another 6, 8, 10, 12 years before it goes to another professional who knows what they're observing. Whereas in an institutional setting like Fjodor, you're constantly monitoring those things. So sometimes, you know, people in our situation have to make a decision that is, you could kind of look at it and go, well, it's fine now, but is it going to be fine in 10 years? Is it going to last that service interval? Whereas you don't have that question in an institutional setting. It's, you know, is it fine now? If so, then good, because I'm going to look at it again next week or next month. And I think that does make a big difference as to how you kind of answer those dilemmas.
Yeah, that reminds me of, I was self-employed for a bit and I worked for a couple of clockmakers who were self-employed. And most customers came in with a story that basically began, it ran great for 30, 40, 50 years and then it stopped. So you already know, like,
That's right, yeah.
this might be a little bit of work. And in an institution like this, like I said, I see the clock, I get really, I don't know if this is the wrong word, intimate, but I get to know all the clocks. So some clocks, when I'm winding them, I already hear like, oh, this sounds different. It's time for you to come back.
I think
that sense of ownership. Seth, do you have something to add?
Yeah, sorry, it's also in the commercial setting that Dale was referring to. I mean, for instance, that clock in your presentation where it might have failed or stopped working for one reason, but then you find other things that are wrong. And so do you fix them or not? Because they might not be the reason that it had stopped functioning in the first place. And it's in something that might have been running for a very long time. It can be a combination of things. And unless you fix all of them, you don't necessarily, get it working again. I have that with watches as well.
I think there's also a bit with a different value being placed on the clock. Like Dale's clock, the customer had a very emotional value, but for a closed institution like us, it's less of an emotional value. So also it's more a historical or financial. I think for our collection trust, and most receive historical value. So you'd also make slightly different decisions. Like, for example, maybe keeping that blob of hard solder just because that little bit of solder has a history to the customer's father.
Thank you. Yeah, great. That's exactly what these sessions are about. And it's going to be a common theme as long as we run them. Another common theme, hopefully, and I know there was some correspondence between Francoise and Ken, who were involved in a conservation project on an object that involved the conservation of electronic components, and that's broadly or mildly allied to the conversation this evening about digital. So I was wanting to ask Daniela, I mean, a couple of points there in your presentation, Daniela. As I said, the thinking is so critical, which is why we're here. But Ken, obviously that project could maybe benefit from a form of digitization. But Daniela, I think in the other correspondence, you were saying that you're actually going to try this more in the museum. Can you tell us about that?
Yeah, I mean, this is breaking news. It's very early days, but this clock that you can see in the background, maybe I can zoom in a little bit for you. Don't know if you can see, it has a huge count wheel on the back, and it doesn't always strike correctly because that wheel is very worn, especially around 1 o'clock, where it has like tiny little landing spot for the detent to land on. So I've been trying to speak with people who might be able to do a recording, and once we have a recording that's good quality, that's basically simulating the mechanical sound, we can continue to run the clock telling the time. So you'll still see, from being in the gallery, you'll still see the clock hands moving around, and they'll be driven by the actual clockwork, but the strike train won't be wound up, and instead there'll be an Arduino that plays through some speakers the sound file, and it's programmed to do it every 15 minutes because this is actually a grand sonnery striking, so there's a lot of bells going on with it. And of course, the more it runs mechanically, the more that detent is scraping around the count wheel and pulling off little microns of brass, and the striking is just getting more and more damaged and out of sync. And unless we were going to make a new count wheel, which is a different approach, more of a kind of restoration approach, or perhaps conserving the craft skills rather than purely the functionality, then this Arduino and digital playback seems like a good option.
Yeah, and I think as Julius, in fact, in the chat pointed out, with that clock, presumably it's at least an 8-day clock, is it? It's maybe month going or something, I don't know. But of course, in an institution like a museum, where the doors may be open at, I don't know, 11 or 10 in the morning and close at 4 in the afternoon, the vast majority of the time, you are paying a price with wear or damage, if you call it damage, and getting zero benefit from it. So I really hope within this group and beyond, and not just clocks, of course, we want to encourage conservators of all kinds of dynamic objects to chip in, that could be massively beneficial. I know that I saw we've got Sean here, Sean Martin, who might actually be at Anglesey now as a conservator. So at some point, Sean will be knocking on your door and seeing if you can comment on that. And Julia's too, as well. So it would be really great to develop this this conversation. Bit of a cheeky one before we close, from Chris to Fjodor, about those Volimy movements, Fjodor. You may choose not to comment, but how much of what we see, I mean, this is again an ongoing question or part of the dialogue in conservation. Is it the real thing? How many of those movements were in fact replaced by Volimy? Can you give us any sort of indication?
That's going to be difficult to put a number to. I mean, for those who don't know, I don't think it's a secret that Mr. Benjamin Louis Volimy was, let's say, not a big fan of French clock movements. So he made a decision to change the clock movements for what clocks of his own making. I think it is a fair amount. At least the French cases, a fair amount will now have a Volimy clock movement inside. The really special, the really good ones, he was good to leave alone, but most of the, let's say, the more simpler, so just time and strike movements will have been replaced by clocks of Volymy's making, but I'm not really sure what number to put on that.
Thank you. It was a bit of a cheeky question, but it raises that point again, doesn't it, of the real thing? And
is it still original?
Exactly, that old chestnut, which hopefully we will go on to explore more. We'll probably bring it to a close there. So just from ICON, thank you so much to our speakers and panelists this evening. Yeah, what we're trying to do here is build this community and ongoing nature. So please do get in touch if you know or you are a conservator of other dynamic objects, whatever they might mean, things that move. And we'd love to hear from you in future sessions. And maybe a last word before we say goodbye is that for those of you interested in horology, we always like to give a shout out to the Antiquarian Horological Society. And this Saturday, I believe, is their AGM event, time and observatories. So you can log on to the AHS, that's Antiquarian Horological Society, free to attend event with some really high quality lectures there. So until next time, from our dynamic workshop number 2, we thank you for attending, and we will see you again.